Okay, so hey everyone, today I'll be explaining differentiation, which is the process of using derivatives. Since most people in the UAE at least were absent when this was covered. And derivatives is really important. You need it in IGs, you need it in periodics, you need it in AMSs, you need it a lot for the next two terms. Anyways, before I start all of this, I'm gonna start this question because Hala told me she solved it using her logic, and I don't know the way she solved it. I'm gonna have to see it later, but I'm gonna show you the correct mathematical way of solving it. Okay, so before I actually start working on this, I'm gonna need to introduce you guys to two topics. First, a root. A root is not this root, by the way. I'm talking about not this one. I'm talking about a root when the equation of or a curve or anything or function when f of x, let's say, equals to 0. This is a root of this function f of f. Okay. In other words, it's a solution to the function. Okay, and now that you know this, now that you know what a root is. For example, here in graphs, it's when it passes through the x-axis, when the graph passes through the x-axis. Because remember, f of x is y basically. F of y equals f of x. So when f of x is 0, y is 0. So it's when the graph has a value of y to be 0, which means it passes through the x-axis. So here you can see it's here. It's at this point, which is -3. Okay, so the root for this graph is -3. Keep this in mind. We will need this later. So now that you're introduced with roots, now I'm gonna need to introduce to you guys the concept of real roots and imaginary roots. Real roots is a solution to the function or any graph or curve. Let's say f of x again equals to 0. This is a root where the solution is equal to a real number. So where the solution is a real number. So 1, 2, 3, 4, 5.7, pi over 2. I don't know, any number, any real number. Okay. Now you also have imaginary roots. Imaginary roots are roots where it's not possible to express it in a real number like plane, in a real number definition. So for example, for let's take the answer, this part, x squared plus 9. X squared plus 9 equals to 0. Because remember, a root is when f of x equals to 0. This is a factor, so it's going to equal to 0. Equals to 0. You take 9 to the other side. X squared equals to -9. Now, in terms of real numbers, this is undefined. You can't have a number that, when squared, will give you a negative root or a negative square. Sorry, this is simply not possible. The only way this is possible is if you express it using a complex number, which I won't get into, but like the imaginary solution or the complex solution is going to be x equals to 3i. So 3 I. This is the solution to this. Where I is an imaginary number. This you don't need to know, and I won't get into it because then it's gonna get really complicated and messy. So all you need to know for this question is the concept of a real root and an imaginary root. Okay. Now, if you notice here, this graph only passes through the x-axis once, so it only has one real root, right? It only has one real number that it can pass through to make it actually defined. So now that we know this, let's start working. We start with the first one, f of x equals to k x plus 3 cubed. What this means, it's k into x plus 3, x plus 3, x plus 3. Okay? This essentially means that we're gonna have the function or the graph passing through -3 three times. Because solve it here. X plus 3 equals to 0, so x equals to -3. Same thing here, same thing here. So this means this graph, whatever, should pass through -3 three times. But it doesn't. So this is not the correct solution. This is incorrect. Okay, so now we move on. I will leave the last correct solution till the end. So we're going to move on past it. F of x equals to k into x minus 3. We don't need the k because it can be anything really. X minus 3, x squared plus 9. Yeah, no, minus 9, sorry. Squared minus 9. So now we know this is x equals to 3. Or x equals to 3. And this one is gonna be x squared is equal to 9 because you took 9 to the other side. This equals to 0. So x squared minus 9 equals to 0. So you took 9 to the other side. X squared equals to 9, which means that x equals to 3. Now, this is immediately wrong. Why? Because it only has one root. It only passes through the x-axis once. Here you have two different x values, which is not possible because here, that by this logic, this should be something like this. So we keep going. This should go like here, something like this graph. But it doesn't do that. It doesn't pass through 3. It only passes through -3. Okay, so moving on to the one after it. X minus 3 into x squared plus 9, right? So this, I don't even need to check the next one, the next condition, because x minus 3 equals to 0. So you take the -3 to the other side, x equals to 3. Does x pass through 3? No, it doesn't. It passes through -3. So I don't even need to check this other side. Which if I were to do, it would give me a complex or an imaginary root. So let's solve it. X squared plus 9 equals to 0. So x squared equals to -9, which is undefined. So write undefined. Okay. So basically, it means we have one real root, which is satisfying the condition that we have. However, the root itself is not correct because x equals 3, according to this equation, x equals to 3. But here and on the graph, x equals to -3. So it's not correct, leaving only this one. X plus 3 into x squared plus 9. Let's try it out. X plus 3 into x squared plus 9. Okay, x plus 3. You take x plus 3 equals to 0. X equals to -3. Which so far is satisfying our condition because here again it passes through -3. Now we need to check for this one to see if it's a real root or not. Because if it's a real root, that means the graph has to pass through this number, which means it would have two roots, but we only have one root. So we need this to be an imaginary root. So let's see. Even though I already tested it at the start, but for the sake of actually explaining, x squared plus 9 equals to 0. So x squared equals to -9, which is undefined. We said this in the other ones. So I'll just write undef. Okay, which means that this is imaginary, which is a correct solution, and the correct thing to the graph, because it only means that we have one real root passing through, and here, as you can see, one real root is passing through. So this is our answer. Now that I've explained this, the rest of the quiz should be uploaded in a bit. Anyways, now we'll move on to differentiation. I split the paper into two parts. Part one is the first 15 questions. And by the way, I will send the unsolved paper. This is solved by me. I'll send the unsolved paper here, the actual questions, down in the link description. And it should be on the regional group if you're in it. Also, I will also put the actual proper marking scheme. But why didn't I use this? Because here I told you I split it into two parts. The first part's only the 15 questions. I'm gonna make another video like maybe next week, explaining the last two questions here, question 16 and 17, because they need a video of their own, and it's not something we really took, but it's needed. Like they might ask it in an actual IG exam. Okay, so these will be explained next week, maybe tomorrow, whenever I feel like uploading it. Okay, so we'll start with the first 15 questions, or part one. Okay, we start. Before I start with anything, I'm gonna need to explain the notations, because without a notation in differentiation or derivatives, you will not get the mark. Like for example, let's say we have y equals to 5x squared minus 4x plus 2. Okay? The way you would do it, you would first have to write down either these are the notations. These are very important. Keep these in mind. You'd either have to write dy by dx or y prime or d by dx or f prime of x. These are acceptable notations. However, just to be on the safer side, now I was told all of these are accepted, all of these are fine. But strictly mathematically speaking, for this one, for this specific equation, like if you have a y equals, the last two are not allowed. The last two aren't proper notations. You can only really use the first two for this one because remember, you differentiate what dy by dx means. Differentiation with of y with respect to x. Okay, so you need to have a y, right? You need to have a y. Uh, Without it, like for example, if you have f of x equals to the same thing, so let's just say 5x squared minus 4x plus 2, then you would be able to use d by dx or f prime of x. However, at this level, I think at our level, we're allowed to use any of them. So it doesn't really matter. But to be safe, just like to be safe, if you have a curve, if you have an equation with y equals, use the first two. Preferably use y prime or dy by dx. They're both really fine. If you're like on a time crunch, like you barely have time, use y prime. We use y prime equals to the derivative. I'll explain the derivative rule now. Let me just get through the notations first. You can also write dy by dx. I also said this. Now, for a function, you either use d by dx, even though I just wrote them up. So d by dx equals 2, or f prime of x is equal to blah blah blah, whatever. Okay, so these are the notations. If you have y, either use dy by dx or y prime. If you have a function, d by dx or f prime of x. Or if you have, like, for example, they tell you differentiate. So I'll just write diff x cubed. Okay, here you would use d by dx. Now the difference is here. Uh, why don't you use dy by dx here? Because here instead of y you have f of x, so you don't have a y. So why would you include the y in the derivative? So it's gonna be d by dx. Same thing here. So because you have y prime, because from the y f of x, f prime of x, f of x doesn't really need to be explained. Here, same thing. You don't have a y. If you had y equals into x cubed, you could use dy by dx. However, I think at this level, and I'm saying this from now, I think at this level, at the level we're taking derivatives, all are fine, all are accepted. So, but just to be safe, just remember these. Okay. Now to get to the actual differentiation. If you have an equation y equals to n to the power of x, okay, what you're gonna do, dy by dx equals to you multiply the what was it called, the exponent by the number, so it's gonna be xn, and then x minus 1, so the exponent minus 1 less than the exponent. Okay. So let me explain this. Let's use that example up here. Y equals to 5x squared minus 4x plus 2. Okay, so yeah, given this equation, dy by dx would be 10x, because remember, you take this, you multiply it, then you reduce it by 1. So it's actually 10x to the power of 1. 5 times 2, 10, then x, then 2 minus 1 is 1. But and remember, you should know that you don't really need to write the ones. Minus, this is 4x to the power of 1. So I multiply 4 by 1, 4. X to the power of 1 minus 1 is x to the power of 0. Now remember, any number to the power of 0 is just 1. So it's actually 4 times 1, which is just 4. And now, the derivative of a constant is 0, is always 0. So this is going to be plus 0, which you don't write. So it's really, the derivative is just this part. Okay, now we'll get another example. y equals uh, 2x cubed minus 4x squared plus 5x minus 7. Okay, so now dy by dx, or y prime of x, or should y prime of x, y prime, anything. Y prime is this. Dy by dx equals to 3 times 2, 6. Then you reduce the coefficient by the, sorry, the exponent by 1. So 3 minus 1 is 2, 6x squared, minus 4 times 2, 8. 2 minus 1 is 1, so 8x, plus 5 times 1 is 5. So this is not plus, let me just fix this. Plus 5 times 1 is 5. Then 1 minus 1 is 0, so it's just going to be 1. So plus 5 minus 7 to the power of 0. Because remember, constants have a degree of 0. But you don't multiply it. So just remember, anything, or you can multiply it. Actually, it would make sense because 7 times 0 is 0. So minus 0. So the derivative of a constant is always 0. Keep this in mind. Right? So this is the derivative of this. Okay? Now that you know this, you're gonna move on to the actual worksheet now. So let's start. Easy question at the start. Y equals to 2x cubed plus 3x squared minus 5. Right? Now, multiply 3 times 2, 6. Reduce it by 1, squared. So 6x squared. Right? We'll just write it down. 6x squared. Now, 3 times 2 again, 6. So plus 6. Then 2 minus 1 is 1. So it's going to be 6x. Now the constant, again 0, so minus 0. You don't write it down. So 6x squared plus 6x is your final answer. Okay. A curve has the equation y equals x squared minus 4x plus 1. For this curve, find dy by dx. Okay. So dy by dx equals to 2 times 1, because remember here it's 1. 2 times 1 is 2. 2 minus 1 here. So 2 minus 1 is just going to be x to the power of 1, or x. 4 minus 4x. The derivative of 4x is 4. Because remember, it's going to be x to the power of 1. 1 minus 1 is 0, so it's just 4. The constant's always 0, so 2x minus 4. This is your answer. By the way, these letters here and near the ticks and the red pen, ignore them. They're just the assessment points. They're even here. Just copy them. If you were to do the paper by yourself. Okay. The coordinates of the turning point. Now, this is something I need to explain. Given the derivatives, so derivative of a function, so dy by dx. Okay, let's say the derivative of a function is 3x squared, or no, let's not do that. 3x minus, or actually, no, let me just get a function, like an actual, so f of x equals to 6x squared minus 3x plus 4. Okay, the derivative of this, so f prime of x equals to 2 times 6 is 12. 2 minus 1 is 1, so it's x minus 3 plus 0. So this is the derivative, right? When you want to find the turning points of a function or a curve or whatever they give you, okay, you set the derivative equal to 0. So here it would be f prime of x, or dy by dx if they gave you y equals to 0. Okay, so what we're gonna do, 12x minus 3 equals to 0. You take 3 to the other side, 12x equals to 3. X equals to 3 over 12, which equals to 1 over 4. Okay, so far we have 1 over 4 is 0.25. I'll just write it down. We have 0.25, but we want the coordinates of the turning point. So we want the x and the y. What is the y? How to find the y? how to find the y of the turning point? You put this value, you get the value you found from the derivative equals to 0. You set it back all the way in the original function or equation. So f of 0.25 equals to 6 times 0.25 squared minus 3 times 0.25 plus 4. Remember, I'm just copying over the equation, the function, just substituting 0.25 for x. So this will equal, you do it on a calculator real quick, so 6 times 0.25 squared minus 3 times 0.25 plus 4. This is going to give you 3.625. Okay, so the turning point of this function, here is this 0.25 for the x and 3.625 for the y. Okay, so now that you know this, the coordinates of the turning point. So you found your derivative, right? For the first one, 2x minus 4 is equals to, is the derivative, sorry. So you set this equal to 0. 2x minus 4 equals to 0. Take 4 to the other side. 2x equals to 4. X equals to 4 over 2. So what you know, one of our coordinates is 4 over 2, which is 2. Right now we need to find the y. We substitute it back in the origin. We substitute the x back in the original equation. So y equals to 2 squared. Here, y equals to 2 squared. I put this in brackets. Minus 4 times 2 plus 1. Okay, so this is going to be 4 minus 8 plus 1 is equal to y. Okay, so y equals 4 minus 8 is negative 4. Negative 4 plus 1 is negative 3. So y is equal to negative 3. This is our turning point. Okay, so our final point is 2 and negative 3. Okay, this is our point. So you get your marking points for writing 2x minus 4 equals to 0. That's a method mark. Then you find the x equals to 2. That's the answer mark here. And you use the other one to find the other answer mark, which you find the y, which is negative 3, by like solving and substituting. That's the third mark. And then you got the mark for just in general. You know. Okay. Now, state to the reason whether the turning point is a minimum or a maximum. Okay. For quadratics, now keep in mind this only works with quadratics. For cubics, I will teach you a way later at the end of the video because they do ask for cubics. Or actually, I might just teach it now after I cover the quadratics. Okay. So say you have this. Let's just use their thing. X squared minus 4x plus 1. That's the thing. That's the equation. Okay. Now, you check if this quadratic is a negative or a positive quadratic. How do you do that? By the x squared or any number squared, like 5 squared, 5x squared, for example. The thing with the x squared, the highest degree, if it's negative or positive. If it's negative, it's a negative quadratic. If it's positive, so y equals to x squared minus 4x plus 1. Okay, this is a negative quadratic here. Just write negative. Here it's gonna be positive. Okay, so now if it's a negative quadratic, think of it as a sad face. So it would go like this, something like this. Okay, this means it would have a maximum point. It won't have a minimum point. Meanwhile, here in a positive quadratic, think of it as a happy face. Positive, so you're gonna be happy. It's gonna have a minimum point. It won't have a maximum. Okay, so using this knowledge only for quadratics, we're gonna apply it to the question we just had. Sorry. So we move on here. State with the reason whether the turning point is a minimum or a maximum. Okay, knowing here it's a positive quadratic, you're gonna do that this, you're gonna say, sorry, that this is a minimum, because again, positive quadratics have a minimum. The reason, The equations are positive quadratic equations, and there are no maximums in positive quadratics. There are only there's only minimums, because it goes like this. It goes like this all the way until infinity. It just goes like this. So there's only a minimum, no maximum. Okay, so now find the equation of the line of symmetry of the curve y equals x squared minus 4x plus 1. We did this. We did this in the like previous sections. What it is, the line of symmetry. This is in the canonical form thing. So y equals to what was it? K or no? A x minus h squared plus k. This is our standard form. Okay. So the line of symmetry is gonna be x minus h equals to 0, because this is the x coordinate of the vertex. So it's gonna be like this. This whatever. I'm not gonna explain this. You should know this. So you solve it. You find whatever's here. Negative h is equal to whatever. Line of symmetry is the x coordinate. Is this thing here? Whatever. Okay, it's the x. I can't say this properly. It is the x value of the vertex or the turning point, which in this case is h. Okay. So the abscissa of the vertex is equal to the line of symmetry. We found the abscissa of the vertex or the turning point. It was 2, -3. Okay. So the thing is gonna be 2. Simply, it's just gonna be x equals to 2. Do not forget the x equals. The x equals is very important in the line of symmetry. X equals to 2. Okay. This is our line of symmetry because it was 2, -3. Perfect. So now moving on. For the curve of the equation y equals to 4x squared minus 2x plus 5. Find dy by dx. Okay, so simple. We do this properly. I'm sorry, I'm kind of doing something right now. Dy by dx equals 2. You derive now. 3 times 4, 12. 3 minus 1, 2. So x squared minus 2 times 1 is 2. And then the constant is always 0. So it's just going to be this. Okay. Find the coordinates of the 2 points on the curve where the gradient of the curve is 1. Similar to what we did, but instead of substituting dy by dx equals to 0, dy by dx is going to equal to 1. Okay? So the derivative is going to be equal to 1. So 12x squared. No, it's here anyway. 12x squared minus 2 is equal to 1. So 12x squared minus 2 minus 1. You turn it into the quadratic equals to 0. Then you start factoring, right? You factor it out. Sorry, you factor it out, then you solve. Now I'm gonna solve this using the. I don't know what I did here because it's actually very messy. But let's just go up from here. Actually, I don't think you can factor this. Never mind. Don't factor this. Okay, I figured out where I was. You take this to this side. I don't know why I did this. Whatever. I think I ran out of space. Anyways, that besides the point. Continue from here. 12x squared equals to 3. Okay, I'm just gonna use a different color. This isn't very good. Did it change? Yes, it did. Okay. 12x squared equals to 3. So then you're gonna divide by 12. X squared equals to 3 over 12. So x squared is actually gonna equal to 1 over 4. It's equal to 1 over 4. So then you do the root. So x equal to the positive or the negative of 3 over 12. Because keep in mind, you can have two numbers that will give you 3 over 12 when it's squared. Okay. Positive and negative root 3 over 12 because you wanted to get the x alone. X equals 2 plus or minus 1 over root 1 over 4. Now to solve this, again, you should not evaluate fractions and roots. 1 over 4. This means it's going to be root 1 over root 4 which is just going to be root 1 is 1, root 4 is 2, because remember 2 squared is 4, so 1 over 2. So x can be positive or negative 0.5, because remember 0.5 is 1 over 2. Okay, now you split this up. So x can be positive 0.5 or x can be negative 0.5. Okay, so then they gave you the 2 points here. So you write down 0.5 and negative 0.5, right? You substitute this back in the original equation like we did at the start. Sorry, so the audio cut, where was it? Okay, the audio cut, so I have to restart the thing. Last I checked, I was here. Okay, now to solve this, you substitute negative 0.5 into the original equation. So y equals 2, let's go up and look for where it is. 4 negative 0.5 cubed minus 2 times 0.5 plus 5. Y equals to 5.5. You do it on a calculator, you'll get 5.5. So when x equals to negative 0.5, which is here, y equals to 5.5. Okay, now you work for the other solution. You find when x equals to positive 0.5. So y equals to 4 0.5 cubed minus 2 times 0.5 plus 5. Y equals, so let's do this on a calculator. You'll get y equals to 4.5. Let me just check if it's actually correct. Yeah, okay. Y equals to 4.5. So when x equals to positive 0.5, y will equal to 4.5. Okay, my god. So we were here. We did this. Question 4. A curve has the equation y equals x cubed minus 5x squared plus 8x minus 7. Find the gradient of the curve at 2 and negative 3. Okay, so you find the derivative, right? To find the gradient, I forgot to actually explain what the derivative actually is. It is how you find the rate of change, or like at the gradient. Basically, the gradient is the rate of change, the slope, at a certain point in the graph. Okay, this is you should know this from grade 7 math. The slope is the rate of change. Now, find the gradient of the curve at negative 20. So what you have to do, you have to derive. You have to find the derivative. So dy by dx is equal to, so here equals to uh 3x squared plus or minus, sorry, minus 10x 8x, so this is just going to be 8, and then the constant stays the same. This is our derivative. Now you substitute the x value in our x thing, on our x in our x function here, the derivative, whatever it's called. Yeah, the derivative. Okay, so 3x squared, so 3 2 squared minus 10 times 2 plus 8, okay, is equal to the gradient, which we'll label as m, where m is the gradient. Okay, now you solve this. So m is going to equal to, you do it, uh 3 squared is 3 times 4, so 3 times 4 minus 20 plus 8, because 10 times 2, 0. So m is equal to 0. Okay, now I explained this before. When the derivative dy by dx is equal to 0, it is your vertex, it is your stationary point, right? So what you write, it is a stationary point or the turning point. Now, what if they extend this question and tell you, uh, is this point a minimum or a maximum? Now, I believe this would be a minimum since it is a positive cubic and there isn't a repeated root, but we need to verify this, right? The way we verify this is by getting the second derivative. Okay, the second derivative basically tells you if the point you or the way you use it as far as you're concerned, even though it's not in the book, the way they're gonna teach you if a point is minimum or maximum, they're gonna tell you to construct a table of variation. The table of variation is long, it's annoying to solve, and it's not really the best way. The way you would do it, the quick way you would do it is you would do the second derivative. Now, how do you denote it? Because again, notations in derivatives are very, very, very important. Don't get marks without denoting. The notations in a derivative, you can either write d squared y by dx squared, or you can write f prime prime of x, or you can write y prime prime. Okay, then you can also write d squared over dx squared, but whatever. Besides the point. So again, you derive you get the second derivative. Now, how do you get the second derivative? You derive your first derivative. So what was our dy by dx here? dy by dx was equal to 3x squared minus 10x uh, plus 8. Just make sure. 3x squared minus 10x plus 8. Okay. So then you derive this. So d squared y by dx squared is equal to 6x and then minus 10, the constant is 0. So this is your second derivative. Right. Now, before I actually start solving, you need to know if your second derivative, I'll just note it, denote it by y prime prime since I don't need to write all this again, is greater than 0, then the point you have is a minimum. Okay. However, if your second derivative, the point you choose at your second derivative is less than 0, your point is gonna be a maximum. Okay. Now, if y prime prime equals to 0, then your test is inconclusive, and then you would need to construct the table of variation. So I'm just gonna write inconclusive. Now, the times that they would do this is maybe in a saddle point, which you should take in the actual IG class, and I won't explain this because it's annoying to explain. However, uh, to define whether a point is a minimum or a maximum, you get you just have to memorize this, the second derivative and its properties. Okay. So now, what was our point? Our point was 2 and negative 3. So 2 and negative 3. Okay, substitute it in. So d squared y by x squared uh, at x equals to 2, or let's not denote it like this. Let's just write 6x minus 10 is equal to d whatever. خلاص, let me just actually probably solve it for once and for all. So 6, you substitute in the x value, 2 minus 10. This will give you 12 minus 10, which will give you 2. Now, 2 is greater than 0, which means that this point is a minimum. Okay. And it's a turning point, of course. It's a vertex or a stationary point. It has 4 names. The velocity and acceleration displacement questions, I will skip them because we didn't take them. It's mechanics, but it's useful to know for the future, and also it's just extra practice. I will skip it. I'll explain it at the end of the video. Okay, so question 5 will be skipped. Question 6, differentiate with respect to x. D by dx. Here notice I didn't say y because there wasn't a y. So 2 times 5 is going to be 10, and then 2 minus 1 is 1, so 10x. That's it. You repeat the same thing here. However, for this is 3 over x, and you remember 3 over x means just 3x to the power of negative 1. Okay, so then you derive this. D by dx is equal to negative 1 times 3 is negative 3, and then minus 1 subtract it with 1, you're gonna get minus 2. This is your derivative, you put it there. Now this one's gonna get a bit confusing, so just stay there with me. Root x, remember, anything square rooted is gonna be to the power of 1 over 2. So here we have x, so it's gonna be x to the power of 1 over 2. Okay, you derive this. D by dx is equal to half or 1 over 2, doesn't really matter, x to the power of 1, oh sorry, 1 over 2 minus 1. 1 over 2 minus 1 is going to give you negative 1 over 2. So negative 1 over 2. This is the x is raised to this power, of course. Which means that this is going to be equal to 1 over 2 x, because remember, if it's negative you take it down, x to the power of 1 over 2, and we just said if it's raised to the power of 1 over 2 it's rooted, which equals, that's an arrow, I don't know why I did that, 1 over 2 root x. Okay, and this is our final derivative. So moving on, question 7. The diagram shows the graph of y equals x cubed minus 12x plus 17. uh, A is the maximum point, C is the minimum point on the curve. The curve crosses the y-axis at B. For the equation, find dy by dx. Okay, so you derive for the first question, really easy, 3 marks. Dy by dx, of course you can't forget to write it, equals to 3x squared minus 12. Constant cancels out. So this is dy by dx. Okay. Part B. Find the gradient of the curve at B. Okay. B is at the y-intercept. And remember, the y-intercept has a point of 0. And in this case, point B, so 0 and the y value of B. So 0B. Okay. So find the gradient of the curve. You put in the derivative equals to m, where m is the gradient at B. So again, the x value was 0, so 3 to the 3 times 0 squared, because this was our derivative, 3x squared minus 12, minus 12 is equal to m, where m is the gradient at B. So 3 times 0 squared, 0 squared, 0, 3 times 0, 0, 0 minus 12 equals to m. M is equal to negative 12. Okay, that's part B. Part C, find the coordinates of A and C. So again, it was given to us. A is the maximum, C is the minimum. So knowing that those are our stationary points, right? Stationary points are the vertices. These are the vertices. So that means our derivative has to equal 0 at these points. So what we're going to do, we're going to get the derivative, 3x squared minus 12 equals to 0. 3x squared is equal to positive 12. You took 12 to the other side. Divide by 3. X squared is equal to 4. X is equal to positive or negative 2. Now that you know this, what we're gonna do now is we're gonna substitute positive 2 and negative. So we're gonna break it down, positive 2 and negative 2, and substitute these points in our original equation. So let's just put it here. We have 2, we don't know the y yet, and we have negative 2, we don't know the y yet. Now we can tell which point is which. Here it crosses, this is our y-axis, so anything before this is going to be negative, because remember it says here this way is the x positive, so anything here is going to be negative x, and anything after here is going to be positive x. So what we can tell here, since this falls to the negative side and this falls to the positive sides, a is going to be the negative point. A is where we're going to have our negative x. So negative 2, this is going to be a. A equals, and then where our x was positive, c equals blah blah blah, whatever. Okay. Now, what we're gonna find now, we're gonna want to find our y coordinates. So we're gonna substitute. We're gonna go back to the original equation. Y equals x cubed minus 12x plus 17. So y equals 2x cubed minus 12x. Sorry, that just looks like x times 3. X cubed minus 12x plus 17. Okay, we're gonna substitute in these points like we did in the previous questions. Y equals 2. So first we start off with positive 2, 2 cubed minus 12 times 2, then plus 17. So y equals 2 cubed is 8, 2, 4, yeah, 8, minus 24 plus 17. 8 minus 24 is gonna be, let me just write down, y equals 8 minus 24. It's gonna be negative 16 plus 17, which is gonna give us the fabulous point of 1. So when x is 2, y is gonna be 1. Let me just make sure. When x is 2, y is 1. Correct. Okay. So now we find, let me just make sure. Yeah, when x is 2, y looks like to be 1. Yeah, okay. You can find this like visually. Now we want to substitute in negative 2. So y equals 2. Let's go back up here. Y equals 2, negative 2 cubed minus 12 times negative 2 plus 17. Y equals negative 8. Uh, Negative with negative make a positive, so plus 24 plus 17. Okay, so now just erase this. Y equals 2. 8 minus 24, 8, 24, it's actually 24 minus 8. So 24 minus 8 is going to be 16 plus 17, which is equals 33, I think. Let me just confirm with the calculator. Plus 17, 33. Okay, so negative 2 and 33 is our points. Okay, these are our answers. Next question. This is velocity. I'm gonna skip it. Differentiate with respect to x. I just did it. I think there's another one as well later on. Yeah, I'm gonna explain this one instead because this one's a bit harder. So I'll just skip this one. I'll skip this one. We move on to question 10. They're all, by the way, they are all the same concept. Like, honestly, it's a really, really, really easy topic. And the thing is, it's easy, but they're gonna ask you so many questions. You need to be quick with it. So, master derivatives as much as you can. Check the book, check IG past papers, check whatever. These are IG past papers. However, these aren't past papers from Cambridge. These are from Adexel, another company that does IGCSEs. However, they have similar topics, similar concepts. So this is probably what you're gonna find on your IG. This is probably what you're gonna find on the school exams. So you really need to practice your differentiation. Okay, a curve has the equation y equals x cubed. If this thing could kindly go away, x cubed plus 3x squared minus 24x. You differentiate dy by dx is equal to 3x squared plus 6x minus 24. Okay. Find the coordinates of sorry. Find the coordinates of the turning points of the curve. Again, set it to 0. You this time you actually need to factor those. So you know, sorry for people who hate factoring. First, you notice they're all divisible by 3, so you take 3 out as a common factor. X squared plus 2x minus 8. Okay, now that we're here, we are going to want to factor, and this is like basic factoring. Come on, So we're gonna use the product and sum method. So here is gonna be our sum, and here is gonna be our product. Okay. What two numbers when you add together give you 2 and you multiply together give you -8? Obviously, honestly, 8. I would focus on the product because the factors are going to be easier. So you're going to have 1 and 8, or 4 and 2. So 1, 2, 4. These are your factors. Now, if you add 1 to 8, doesn't give you 2. It's going to give you 9. And if you subtract 1 from 8, it's going to give you 7. If you add 2 to 4, it's going to give you 6. But if you subtract 4 from 2, it's going to give you 2. So this is our numbers. These are our numbers, 2 and 4. So it's going to be x plus 4 into x minus 2. Now, since the middle number is positive, that means the bigger number of the two, the bigger factor of 8, is going to be positive as well. Because you remember, you're going to need to sum with a positive number. You're going to have your end of the sum, the result, as positive. So x plus 4 is x minus 2 is our answer. Now, using the product rule, this is obviously going to equal to 0. All of it's going to equal to 0. The derivatives all is going to equal to 0 for the turning points. Using the rule for this, I forgot what it was called, zero product, I think. All of these have to equal to 0. So 3 equals to 0. This is not a real solution. We cross it out. X plus 4 has to equal to 0. And x minus 2 has to equal to 0. So x can be -4, or x can be 2. Okay, so now we're gonna want to do the exact same thing we've been doing for the past 4 questions, which is substitute on these points into the original equation. So what do we have? Let's start on a new page. We have x equals to -4, x equals to 2. Our original equation was y equals to, let me just erase that, this doesn't really look nice. Our original equation was y equals to, oh my god, whatever, y equals to x cubed plus 3x squared, sorry, plus 3x squared minus 24x. Okay, so y equals -4 all cubed plus 3 into -4 squared minus 24, which equals 2. We'll find it later, and then we also have to find for the other case, which is 2. 2 cubed plus 3 into 2 squared minus 24. Okay, so we start with this one. We work on a calculator, obviously. -4 cubed plus 3 -4 squared minus 24 is gonna give you sorry, this is gonna give you another number that I did not know how I got it from. One sec. Just put this in a bracket, even though I don't think it's gonna change a thing. So -40 or -80, because I am missing something on question 10. It's gonna give you -4 and 80. Okay, I don't know where I got -40 from, but I did solve it and I got 80. So -4 cubed plus 3 into -4 squared minus 24. Oh, 24x. My bad. Yeah, I forgot to put 24 uh, into -4 here, and somewhere up above as well. Okay. I actually don't mean to do that. Okay, let me just fix this. 24x, and here into -4, which we're gonna solve as well for this one. So into -4. which equals 2. Whatever. This is going to be negative 80. So our first coordinate is negative 4, negative 80. Now, second one. We just changed the numbers. We changed the calculation to 2 instead of negative 4. So this is going to be, you do it on a calculator. This is going to be, second, I put a point and it gave me a number. That's slightly concerning. Negative 28. Okay, negative 28. So our second point is going to be 2, negative 28. Okay, that's another discussion, I believe. Yes, it is. And another one, next one is mechanics. So we're going to skip it. Differentiate with respect to x. I'm going to skip it. Okay, so question 13, y equals x squared minus 16 over x. Find dy by dx. Simple. Dy by dx is equal to, try to go through this quickly, is equal to 2x minus, and again you take this to be 16x to the power of negative 2. Okay. Or negative 1, sorry. Why did I take it to negative 2? 16x to the power of negative 1, right? This is just erase this and fix it. Just erase everything. Okay, so let's actually, first of all, before I actually start solving, let's rearrange it. X squared minus 16x to the power of negative 1. Okay, so now dy by dx is equal to 2x. Now, here this would normally be minus whatever. Here this would be, first let's derive this on its own, right? Let's do dy by dx on this one. Dy by dx equals to negative 16 x to the power of minus 1 times minus 1 subtracted from 1. It's going to be minus 2, right? Now this is going to be minus 16 x to the power of negative 2. Okay, minus with a minus make a positive, so this is actually going to be 2x plus 16 uh, x to the power of negative 2, because remember when we derived this part of it, 16 negative 16x to the power of negative 1, we got negative 16x to the power of negative 2. So we have negative and it's minus, so it's minus with a minus, positive. So this is our answer. This is our derivative. Just gonna remove everything. Okay, moving on. The graph shows blah blah blah. The point P is turning point of the curve. Work out the coordinates of P. Okay. P is a turning point, so our derivative is going to be set to 0. I'm going to take this away. So dy by dx is going to equal to 0. What is dy by dx equal to? 2x plus 16 x to the power of negative 2. Now keep in mind, you can rearrange 16 x to the power of negative 2 and change it into 16 over x squared. Okay, yeah, just so you know, you can make your life easy on yourself. So let's actually set it to that. So 2x plus 16 over x squared. This is our actual like derivative. Okay, this is going to equal to 0. Now take this to the other side. 16 over x squared is equal to 0. Multiply by x squared, or sorry, equals to negative 2x. Negative 2x. We're gonna multiply on both sides to get to cancel it. So x squared here, and we're also gonna multiply by here times x squared. Because you know, when you multiply on one side, you're gonna have to multiply on the other. Same with the division. This x squared will cancel with this x squared. So this is gonna be 16 is equal to negative 2, and x squared with x make x cubed. Okay, so negative 2x cubed, let's just rearrange, is equal to 16. Divide by negative 2x cubed is equal to negative 8. Now, because this is an odd exponent, you can have a negative root. So x is equal to the third root of negative 8. This will give us x to be negative 2. So we know that one of our points is negative 2. Now we just have to substitute this point, substitute negative 2 back in the original equation. Our original equation was y equals to x squared minus 16 over x. Right? So now what we're going to do, we substitute the x here. Y equals to negative 2x squared, oh sorry, negative 2x squared, negative 2 squared minus 16 over negative 2. You should immediately know negative with the negative cancel, so it's gonna, or you can actually just do it like this. Y is equal to 4, because negative 2 with the squared, 4 minus 8, which is gonna give us 4 plus 8, which is going to be 12. So y is equal to 12. So we go back up to where we had it, negative 2 and 12. And that is our answer for the turning point, which is B. The particle moves, we skip this. And finally, differentiate with respect to x. Okay. So first you distribute this, right? To get our actual thing. So 2x multiplied by x raised to x cubed plus x squared multiplied by 5 over x is gonna be just 5x, because the first x, let's essentially split this up. It's gonna be x times x, or xx into 5 over x. Okay, the first x will cancel with this x, so it's just gonna be leaving us with 5x. So plus 5x. Okay, this is our equation. This is not derived yet, keep this in mind. So now dy by dx is equal to 6x squared, then plus 5. This is our answer. Okay. 5 root x. Again, root x is going to be exponent 1 over 2. So 5x 1 over 2. We're going to want to derive this. Dy by dx is equal to half of this. So it's going to be 5 over 2, or 2.5 x to the power of negative 1 over 2. Now, remember, you take this down so we can make this positive. 5 to x 1 over 2. Okay, now again, anything to the power of 1 over 2 is going to be root x. So it's just going to be 5 over 2 root x. This is your final answer here. And this is the end for part 1. Part 2, which is the second part, which is going to be these questions here, questions 16 and 17, since they kind of need a video of their own, will be explained later at a later date. Anyways, good luck, guys. I hope you understood. Goodbye.